Hi, I'm going to talk about the third lab, which is magnetic field of a bar magnet. The purpose of this lab is to explore the correlation between magnetic field of observable distance on and off axis from the source. So the fundamental physical principles used here are PHYS law and magnetic dipole model by bar magnets. The diagram here is the observed model. The system is a bar magnet and phone, and the surrounding is everything else. And for initial conditions, in this case, I haven't really set any initial conditions for this lab. The assumption made is that bar magnet acts as a magnetic dipole. And going back to the principles, there are two main physics ideas. First is PHYS law, which describes the magnetic field generated by a constant electric current. And the second one is magnetic dipole, which is a basic model in magnetism comprising two magnetic poles generating a magnetic field. For a brief preview of the results, magnetic dipole moment is 2.28 ampere meter squared, and magnetic field proportional to distance is negative 3.04. And this is the experimental data on and off the axis. From the experimental data on axis, I was able to calculate the magnetic dipole moment using the slope of ln b versus ln r through the calculation shown. This is the main part of the coding in this lab. I first set the magnetic moment and I calculated magnetic field. Also, I set the observation locations to on axis for perpendicular to the axis. Then I drew arrows representing the magnetic field on each location. Lastly, I visualized the magnetic field. So this is the computational model indicating the direction of the magnetic field on each location. So the errors involved here are: first, the assumptions made were not realistic. Also, we did not consider the magnetic field generated by Earth. So from now on, I'm going to answer two what-if questions. First, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So all of the magnitude readings would have been skewed in the direction of magnetic north, so the values of k, mu, and n would not be as accurate as they are in the lab. Second, what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? If then, the direction of the magnetic field would be the same, but the magnitude of the magnetic field would be doubled. Thank you for listening to the presentation, and this was Esther.